Question number 10. It is true that a zero order reaction is a single step reaction. See, we are talking about first about the zero order reaction. Dear friends, it is a complex reaction, a multi-step reaction. So when I talk about true statement, yes, this is the true statement. A first order reaction is always a single step? No. Second order reaction is always a multi-step? No. So only the second statement is correct, that a zero order reaction is a multi-step reaction. Okay. Let's look at question number 11. The electronic spectrum of TiH2 3 plus shows a single broad peak with a maximum at 20,300 centimeter inverse. Okay. The crystal field stabilization energy of the complex ion in kilojoule per mole is. See, first of all, we have to find out that how many unpaired electrons are over here. Then using the value of this 20,300 centimeter inverse, we will find out the crystal field stabilization energy. The value will come out in centimeter inverse, and then using this conversion we will get the value in kilojoules. Let us solve it out. Starting with titanium, over here Ti is in 3 plus. What is the electronic configuration? 3d2 4s2 is the electronic configuration for Ti. Okay. But what do we require? We require Ti3 plus. So for Ti3 plus, the electronic configuration will be 3d1. Right. Now over here, as you can see, there are 6 ligands, so it will show octahedral crystal field splitting. Now if we go for octahedral crystal field splitting, I will have no electrons in the Eg and only one electron in the T2G. Right. Now the energy difference, that is the delta naught over here, is given to be 20300 centimeter inverse. Right, dear friends. So when I calculate the CFSE, right, so this is 0.6 into the electrons of Eg into delta naught minus 0.4 electrons in T2G into delta naught. Now as you can see, there is no electron in Eg, there is only one electron in T2G, so you will be getting minus 0.4 multiplied by 1 multiplied by, the value is 2300 centimeter inverse. So when you solve it out, you will be getting 8120 centimeter inverse. Okay, but we want the value in kilojoules. So how do you convert this value in kilojoules? You will divide this by, see, the conversion factor is given to us. The conversion factor is 83.7. So I divide this by 83.7, and on solving I get the value as 97 kilojoule per mole. Okay, dear friends, right? The only trick in the question was, rather than simply saying delta naught, they used the statement that a single broad peak with a maximum at 20,300. Okay, fine. Thereby relating it to the delta naught. So the correct answer is option number 2. Okay. Now let us look at question number 12. The complex that can show optical activity. First of all, you should know that these trans molecules have a plane of symmetry, so they will not show optical isomerism. Now let us talk about the first and the fourth one. In the first case, see, you can see this is an octahedral complex, and they are talking about, you know, the cis configuration over here. But dear friends, even in the case of cis configuration, say I have this molecule with me, say Cn, then over here NH3, then over here I got Cn, and here I have got NH3, right. But still, you know, over here you will have to show Cn and Cn. So, you see even in this case there is a plane of symmetry. Let us look at the fourth choice, which is cis. See, this is Cr, this is one chlorine, this is second, and then we have got the oxalate ion. Fine. See, oxalate ion works like this. Okay, O here, O here. So, as you can see in this particular molecule, you are not observing any plane of symmetry, right. So, that is why this is the correct answer, that it will show optical activity.